we should probably make this a little simpler and a little more analog. And I went, okay, that sounds great. And he drew me a little circuit pattern out. Can you tell that I don't own a real camera? But he drew me this. You can see where my positives and my negatives go. They're all color-coded. Yeah, I needed that. And then Jeff made me this adorable little circuit board. It's like 4 resistors, 2 capacitors, and a whole bunch of solder on a tiny perf board. And then I sewed it all up. There's my 234 by 34 ply, because that gets very low resistance. I actually did this with 117/17 ply originally, and it didn't work. That's why I hate conductive thread. Conductivity was terrible, ripped it out, put this in, and then just kind of literally swabbed the entire thing with Fraylock so that it wouldn't come apart and cross. And then I think all of my LEDs might be kind of black now because they're completely covered in glue, conductive glue. But boom, it works. I was really happy. I screamed at my whole hacker space again. I think our vice president was really creeped out. And I'm going to show you a video of, we put the flex sensors in. It turned out they were a little bit trickier. So this is my friend Jeff. Jeff made me this thing. Nope.
And here's the flex resistor.
I know it's hard to hear.
All the way over, and hey look, there the LED lights up. And it's even a little bit variable too. Pretty cool.
He's right. Anyway, he was showing me that it took 3 volts, in case you couldn't hear that part. The beauty of these things, which is what that's trying to show you, is that as you flex them, the resistance changes. Flex them one way, it goes down. Flex them the other, it goes up. So you can use that to tell, through a circuit, to tell your lights to light up. This is the circuit he made. I don't know what any of that means. But he tells me it works, and I believe him. So again, that's the little circuit board I showed you beforehand. And then after that, I started sewing the flex sensors. I sewed them into the crooks of both arms and attached some really, really long wires to them. And then I sewed fabric over them because, interesting fact, flex sensors are shorted out by human skin. Anyway, those got sewn down and assigned to their respective places on the circuit board, and that was put into my little pouch that I have right here, along with my batteries. There's 2 AA's powering it, and one of the flex sensors turned out to be defective. This jacket was the devil. So Jeff replaced that one with a with a regular resistor. That's in here, there, and then this one's still here, and we finagled it together to make sure that this one works, and this is a little bit less sensitive. So I can show you me wearing it, but I can also show you this video of me dancing around being really happy.
The new look.
Yeah.
It's awesome. Oh, and there Nate comes out of our TARDIS with a jigsaw, and I ran. Does it work if I do this now? Bam!
Yeah.
Bam! Yep. Yes! Oh, I was really excited. Thank you. Wait. I can do it for you too, but very briefly, because again, the conductive thread is really finicky, and so most of these probably won't light up like they're supposed to. So wait. Nikki, tell me if it's working. Boom. Yay! The fun part was that I got to premiere this at a huge dance party. So, boop, boop, boop. Lots of good stuff. Okay, other stuff besides my own. This is the good stuff, guys. Here's Jeff Kantarek again. He's Speed Racer. He was a professional electrical engineer until he became extremely happily unemployed. Now he mostly just builds things with a startup company and helps everyone around the space, yours truly included, figure out what they're doing wrong with their projects. He is creating a biofeedback shirt. You can see all of his components. They're kind of messy. It's still currently in progress, but I'd like to update you on how it's going so far because I think it's very, very cool. The premise of the project is that it provides biofeedback in order to improve balance for people who have inner ear problems, perhaps, any kind of balance-related issues. It uses a Lilypad, an accelerometer, a bunch of vibration pads, and a LiPo battery, plus a bunch of conductive thread, lots of conductive thread. Here's where he made a huge mistake. Jeff does not know how to sew. He decided that before he sewed it down, or rather had his mother sew it down for him, he was just going to make all the connections. It quickly got extremely tangled. I don't even know what he's doing there. I think he has his vibration pads literally completely wrapped in conductive thread and scotch taped together. It was great, so it was a ton of messes and tangles and frustration, and then he realized that was a bad idea and learned how to sew. He originally used the same embroidery thread that I used for my light bright because it has better resistance, but he had to switch to the 117/17 because it's pretty much the only one that will actually properly knot through the Lilypad. Otherwise, it'll just come apart, which is why I used crazy glue. Yeah, but he drew up a new shirt and sewed the thread properly in and not as messy, and then sewed fabric over it to allow for overlap so that he wouldn't have the crossed wires that you get. The ground connections were completed, an accelerometer was attached to the analog inputs on the main Lilypad, as you can see, like right about there. And he put a little pocket in. Can you see the pocket? No? Okay, well, there's a tiny black pocket down in that corner. I promise you. It's like right there. Right there. Okay? That's where his battery is. And then the vibration pads were attached and sewn to positive leads. These are his little vibration pads. Look how cute they are. I love those components. Those go on the inside of the shirt around your waist, directly attached to your skin. And when your balance goes off center, they vibrate and let you know. This is actually his prototype, so I guess he's moving to talk to other people about it. But unfortunately, he realized that the shirt was a terrible idea, and that a waist belt was a much better one because he didn't have to use conductive thread to do this. This is all, pardon me, regular and analog, and this was his second prototype. And his third will include stretchy conductive fabric because he also realized that it's magically not resistant. Anyway, what was I going to say? Yeah, you can check out his site. That's Effective Engineering. He's got a lot of great projects there, including one that I wanted to show and was unable to because it was never finished, called Warm Strings. Our friend Yasna made it. It is a knit scarf, lily pad, some speakers, and when you touch it, it plays violin. It's very cool. But that's not done, and she avoided me because it wasn't. This is Horace. I love Horace. I have Horace here. Anyone who wants to afterwards can come play with him. Let me tell you, TSA didn't want to let me through with him. He looks like a bomb. Or so the English tell me. I made this stuffed animal. I made 16 of them for a class. And then he took one of my extra ones and attached a battery pack, some acrylic, a couple of these little cell phone vibrator stick things, which are what make his wings. And then he made this huge ball of LEDs and like hot glue. It was like this, and I stuffed it into the belly. Let me make these things work, though. Sometimes they don't go. Oh, yay. Oh, it's spinning. Look at him. They spin. Oh, and he lights up. Nobody can see this, I'm sure, but his buttons light up, too. It's very adorable. I don't actually know how that one works. He never told me. He just said I had to bring it with me. So I did. Now I'm going to talk about a project by John Stoner. John Stoner is a great member of our hackerspace. He is also an incorrigible member of the cycling community in Chicago. He bike rides everywhere, including through our extremely harsh and desperately dreadful winter. And he's also a really good programmer. He made this thing called Boogie Pants, which is really hard to see, I know, but a belly dancer he's working with to do this stole it and wouldn't give it back. So that's the only picture I have. That's from our Geek Prom Science Fair in Chicago. This actually doesn't have any of the components I talked about before. I apologize. It's a little bit different from the rest of the projects, but I think it caters more to the programmers amongst you. It's less an example of electrifying clothing and more an example of how awesome relationships that technology and fibers can have together. It incorporates, again, none of my indispensable components, but I could if you really wanted to get fancy, but it deserves mentioning. It was made using an apron-like garment, which I showed you before, and a Wiimote and a nunchuck, not to mention a pretty good knowledge of Java and Wiimote hacking, none of which I can explain. But John can. This will again be online. This is a link to his site where he has everything completely open source, so that's all of the programming and the back end of it, which is done using pure data.